In this video, we're going to introduce a stack and also how to do separate compilation in Go, which is putting your program in multiple .go files. So here is from Geeks for Geeks, a visualizer of a stack. It's a very simple data structure, and you can think of it like a stack of trays at the cafeteria. So here we have two values in our stack. If we push another value, it simply goes on top. Push another value, goes on top. The peek operator will just look at the top element on the stack, and then popping removes the top element of the stack. So we add things with push, we peek to look at the top element without removing it, and we pop to remove the top element. So that's what a stack is. Now stacks are really useful in one particular case, I mean lots of cases, but one particular case is in implementing reverse Polish notation. So reverse Polish notation is a way of expressing arithmetic expressions without any parentheses. So here we have 3 plus 5 times 7 minus 2. The parentheses are needed for order of operations. But in reverse Polish notation, what you do is you simply put the operands first and then the operator. So 3, 5 plus means we're going to add 3 plus 5 first. 7, 2 minus means we'll do 7 minus 2 second. And then the star will multiply those two results together. And you can see here that it shows how to implement this with a stack. So we push 3 onto the stack, we push 5 onto the stack, now 5 is on top of the 3. We take that plus operator to pop those two numbers, add them together, and put the result back on the stack. So 5 and 3 come off, 8 goes on, 7 goes on, 2 goes on. So we have 2, 7, and 8. The minus will pop the two numbers off the stack, does 7 minus 2, giving 5. And then we multiply the 5 times 8 to get 40. All right, so let's look at what this looks like in Go. So the first thing I have here is stack.go. And I put stack.go in a subfolder underneath my reverse Polish calculator folder. So I have a folder int stack, and I've named this package int stack. So those should match. And this is going to implement those operations we talked about, peek, pop, and push. It's going to implement this using a slice. We've seen before the idea of creating a struct when we were doing testing. So this is going to be a struct. It's basically just a container that holds a slice of integers. And then our functions are going to take a pointer to a stack, and we talked about that before. Because we're going to be changing the stack, we want to pass a pointer to it. We don't want to pass a copy of it. So push will simply append an item to the slice. So we'll just take that value and we'll append it to the slice. Pop will check to make sure that we have some items. And if not, we'll return 0 and false because we aren't able to pop something if there's nothing in the stack. We subtract 1 from the length, and we update the slice. So the element is going to be the last thing in the slice, and then we update the slice so that it has everything except that last thing. So this colon means we'll go from 0 to index minus 1 inclusive, and then we return the element in true. Peek is going to look very similar, except it doesn't actually take anything off. It simply returns s.items at length minus 1. Is empty is a simple function that we can check whether or not there's something in the stack if the number of items is 0. All right, so we can use that to build this calculator. This calculator, you'll see, says package calculator. It's in a directory called calculator. And what it will do is it's going to take in a string and it's going to evaluate it using reverse Polish. So first we get a stack, and then we've created that variable. We've taken the address of it, so we have a pointer. We then parse through the string that was passed in, splitting it up into tokens, basically things that are separated by spaces. Then we're going to loop over those tokens. We don't care about the index, we just get the token. If it's an operator, we pop 2 arguments and we apply the operator. Here we check for errors to make sure those both were okay. Here we check to make sure apply operator doesn't return an error. We can return an error if something bad happens, right? If you say like 5 minus, there won't be enough things to pop, and we'll return an error. And then we push the result. So this is the simple algorithm that we saw on reverse Polish. We pop 2 arguments, we apply the operator, we push the result. If we get a number, then we're going to convert to an integer using this string conversions package. If we get an error, we will return an error, an invalid token. We push that number we have on the stack. If the stack is empty, we don't have a result. Otherwise, we pop. We should be empty now, otherwise we have extra things on the stack, and we return that result. So this is our reverse Polish calculator. We take in a string, and we're going to get back a number after fundamentally pop, and apply the operator, or just push a number along the way. We've included a test case for this. So we, as before, create a table of tests. We name them. We put in the reverse Polish notation, and then the desired result, whether that's a number or an error. And so here 1 plus, there aren't enough operands for that plus, so that should report an error. 1, 2, we have too many things on the stack. A here is an invalid token, that's not a number. And here we're dividing by 0. So that will be our test suite. And we have the simple loop that we've seen before. We loop over the tests. We're going to run that name with an anonymous function that can run in parallel. We'll evaluate using this evaluate function from calculator. If it wants an error, it'll check to make sure it has one. Otherwise, if it has an error and it didn't want one, it'll indicate that. And here, if we didn't get what we wanted, we'll print out that message as an error. Okay, so now we'll look at our reverse Polish. So this is going to import reverse Polish calculator. You'll note calculator imported reverse Polish int stack. And here in reverse Polish Go, so we've imported reverse calculator. We are going to create a new scanner. So this will read in 1 line at a time. We scan, we get the line, we trim the spaces. If it's exit, we break. We evaluate using our calculator, and then we either print the error or we print the result. All right, so I'm going to go ahead and run this in the debugger. So I want to highlight one more thing here. So it's asked for a reverse Polish notation. So I'll say 2, 3 plus. All right, so I've set a breakpoint here. Previously, when we've used a slice, we've called make to create the slice with a particular size. And what I want to highlight here is that's not actually necessary. You'll see that when we've declared this, S is going to contain an empty slice. So it's a slice of integers with no length or capacity and nil for the underlying array backing it. But as soon as we execute that append, now if we look at S, we'll see that it has a length of 1 and a capacity of 1. Okay, so what we've learned here is we've learned about the stack data structure, right, where we have push, pop, and peek, and then is empty as our operators. We've learned about separate compilation, how we can put this code in a file by itself. So we can create a simple data structure here. We can break a large program into parts and compile those separately. And we saw that the package name matches up with the folder name. We talked about reverse Polish notation. and how we can implement that easily with a stack. We've got our calculator, right? So our calculator uses that. We have our user interface, which is simply reading from the keyboard. And I've once again demonstrated some test cases.